Hi, it's Dr. Z. In this video, I will review how to report results for hypothesis tests. By the end of this video, you'll be able to write summary and interpretation statements for two-tailed and one-tailed hypothesis tests for the lecture examples in previous videos. Please feel free to pause the video at any time to take notes. Reporting results involves summarizing and interpreting the data into a form that others can readily understand. For this course, you will learn how to write summary and interpretation statements. The summary statement provides a summary of the results of a research study. The interpretation statement serves as a simple conclusion of a research study. Now that we've introduced our first statistical test, which is conducting a hypothesis test with a z-score for a single score x, the summary statement must be updated. Before watching this video, please review pages 10 to 13 of the chapter handout. This lecture video reviews what the summary and interpretation statements would look like for the lecture examples in previous videos. Lecture example number 1 this week was a two-tailed hypothesis test. Let's review the results of this test. Lecture example number 1 asked the question, do blueberry supplements have an effect on cognitive function? To test this question, a nurse practitioner asked one patient, or a sample of one person, to take the blueberry supplement for 6 months. After 6 months, the patient scored x equals 92 on the Wonderlic Cognitive Ability Test, which measures cognitive functioning. Since this was considered new research, we are not sure what effect or what direction blueberry supplements would have on cognitive functioning. So we used a two-tailed hypothesis test for this research study. When conducting the hypothesis test, we used a 0.05 significance level two-tailed. We then calculated a z-score of z equals +3 for the sample, and we made the decision to reject the null hypothesis. In other words, rejecting the null hypothesis means that something probably happened in our study, and more specifically, it appears that blueberry supplements have an effect on cognitive functioning. Now, let's discuss how to report the results of this two-tailed hypothesis test. First, the summary statement explains what happened in the study. Our updated summary statement will now consist of 2 sentences. The first sentence will briefly describe the study and report the sample score, or the sample mean. The first sentence would be, the patient who had taken blueberry supplements had an x equals 92 on cognitive functioning. The second sentence will report the calculated z-score, the significance level you used, and statistical significance. The second sentence would be this. There was a statistically significant difference on cognitive functioning when taking blueberry supplements. We report our z of +3, and p is less than 0.05. When making the decision to reject the null hypothesis, the direction of the sign is less than. Also, a little friendly reminder, in research we write complete sentences, and that means we need to end our sentences with a period. So let's go to the interpretation statement. The interpretation statement attempts to explain the results of the study in a more simplified way. In other words, it explains the results in a way that your grandma or your nana could understand. So let's reflect on our initial thoughts when rejecting the null hypothesis. Well, we stated that something probably happened. More specifically, we said that it appears that blueberry supplements have an effect on cognitive functioning. I want you to get even more specific. Let's go to the z-score. The z-score was a +3.00, which indicated the cognitive function increased because we got a plus sign. Well, guess what? That's our interpretation statement. blueberry supplements appear to increase cognitive functioning. Not too bad, right? Lecture example number 2 this week was a one-tailed hypothesis test. Let's review the results of this test. Lecture example number 2 this week asked the question, can blueberry supplements improve cognitive performance or cognitive functioning? Well, to test this question, a nurse practitioner asked one patient, or a sample of one person, to take the blueberry supplement for 6 months. After 6 months, the patient scored X equals 87 on the Wonderlic Cognitive Ability Test. Now, after studying the effects of blueberry supplements for several years, it is now considered established research, which means that researchers know in what direction the effect will be. Thus, we used a one-tailed hypothesis test for this particular research study. When conducting the test, we used a 0.05 significance level one-tailed. We calculated a z of plus 1.75 for the sample, and made the decision to reject the null hypothesis. In other words, rejecting the null hypothesis means that something probably happened. More specifically, it appears that blueberry supplements do have an increase on cognitive functioning. Now, let's discuss how to report the results of this one-tailed hypothesis test. The summary statement will use the exact same format as a two-tailed test. The first sentence will report that the patient had taken blueberry supplements, had X equals 87 on cognitive functioning. The second sentence would be, there was a statistically significant difference on cognitive functioning when taking blueberry supplements, our z of plus 1.75, and p is less than 0.05. One-tailed. Ooh. So what's this about? Since we use a one-tailed hypothesis test, we must indicate that at the end of this second sentence. Now, what will the interpretation statement be? Well, let's reflect on our initial thoughts when rejecting the null hypothesis. We stated that something probably happened. More specifically, we said that it appears that blueberry supplements have an increase in cognitive functioning. Well, there you have it, folks. Blueberry supplements appear to increase cognitive functioning. But wait, we're not done yet. What happens if we fail to reject the null hypothesis in our research study? Research does not always result in statistically significant results. Yet, we still must report the results of our data analysis. If we fail to reject the null hypothesis, we will use the wording not statistically significant in the second sentence of the summary statement. Sometimes the z-score calculated in step 3 may come super close to the critical region. Technically, it would mean the study didn't work, but it's so close. So if it's close to the critical region, we can use the word approach significance in the second sentence of the summary statement. You can use either the first or the second choice. Now, what if the sample size was only one person? And, well, what would happen if the researcher had a larger sample size? The z-score for a larger sample size might actually fall in the critical region after all. Therefore, a good ethical researcher will add a new sentence to the interpretation statement about repeating with a larger sample size. So let's see what that's going to look like. For the summary statement, the first sentence would be the patient who had taken blueberry supplements had X equals 86 on cognitive functioning. The second sentence would be there was not a statistically significant difference on cognitive functioning when taking blueberry supplements. Z is plus 1.75 and P is greater than 0.05. Now the direction of the sign will be greater than because we failed to reject the null hypothesis. When we fail to reject the null hypothesis, the interpretation statement will now consist of two sentences. The first sentence will describe the direction of the z-score and reiterate that the results were not statistically significant. For this example, the z-score was a plus 1.50. The plus sign indicates there was an increase in cognitive functioning. It just happened to not be statistically significant. So that will be the first sentence of the interpretation statement. The second sentence is the new statement that a researcher should repeat with a larger sample size. In summary, research involves testing hypotheses using a statistical procedure to determine the results of a study. Reporting results of a study is a critical Lego building block needed to understand statistics.